Hello, guys. Let's talk about significant figures in calculations and rounding. Well, there are two rules that we have to keep in mind. The first one is for addition and subtraction. So your answers are rounded to the least significant decimal place in case of addition and subtraction. And the second rule is about multiplication or division. The answers are rounded to the same number of digits as the measurement with the fewest number of significant figures. Okay, what does it mean in practice? Let's do a couple of examples. So in our first example, we have 4.08 times 2.84. So we are doing multiplication. So remember that multiplication and division has the same rules. Now, if you do this calculation, your calculator will give you 11.5872. Okay, now, how do I figure out how many sig figs do I need to have in this answer? Well, I have to look at the number of significant figures in my values at the beginning. How many sig figs do we have in 4.08? 3, right? How many sig figs do I have in 2.84? 3 again, right? So this means that I need to round my final answer to 3 significant figures also. Now, because my fourth significant figure would be an 8, which is larger than 5, I have to round up. So my final answer is 11.6. Okay, let's take a look at the next example right here. If you do this calculation in your calculator, it's going to give you 9.7398. Okay, how many sig figs do we have in our numbers? 1.50 has 2 or 3 sig figs? 3 significant figures, right? Because the 0 after a decimal point is going to be significant. What about this value here? How many sig figs do we have? 1, 2, 3, 4, 5. 5 sig figs. So we know that in multiplication and division, we have to round our answer to the same number of digits as the measurement with the fewest number of significant figures. So which number has fewer significant figures, 1.50 or 6.4932? 1.50, right? It only has 3 significant figures, so I have to round my answer to 3 sig figs also. My fourth significant figure would be a 9, so again, I have to give my answer rounded up as 9.74. Okay, let's look at our last example on this slide. So we have 4.00 times 4.40 times 1.25. Now, if you do this calculation, you are going to get an answer which is 22. All right, is it the right number of significant figures? Let's see. So in the first value, how many sig figs do we have? Well, in this case, we have 3 sig figs because the zeros after the decimal point are significant. Okay, how many sig figs do we have in 4.40? Again, 3 significant figures because the zero after the decimal point is significant. How about 1.25? Again, 3 significant figures. Now, how many sig figs do I have in 22? It's only 2, right? So I need to add an additional significant figure. In order to do that, I have to add a decimal place and a 0 after it. Now my answer is correct with 3 significant figures. All right, let's do a couple more examples. Let's look at subtraction and addition. So we know that in this case, we have to round to the least significant decimal place, okay? Least significant decimal place. So let's take a look at our first example. If you do this calculation, you are going to get 22.5238. Let's see how many significant decimal places do we have. So we have 1, 2, 3, 4, 5 in this case. So 5 values after my decimal point. 1, 2, 3 in my second number, and 1, 2, 3, 4, 5 in my third number. So I have to round it to the smallest number of decimal places. So how many decimal places can I have in my answer? 3 only, right? Because the smallest number were 3 here also. So I can keep these 3 digits. Now, because my next value is 8, I have to round up. So my answer will be 22.524. Okay, I hope this makes sense. Let's do another one. If you do the calculation for the other one, you are going to get 5.38256. Let's see how many decimal places do we have in our numbers right here. So in the first number, we have 1, 2, 3 decimal places. 1, 2, 3, 4 decimal places, right? And all those zeros are significant because they are after a decimal point. In my next value, I have 1, 2, 3, 4, 5. Okay, which one is the smallest number with the smallest number of decimal places? It's the first number here. So I cannot have more than 3 values after my decimal point in my answer right here. Again, my fourth number is a 5. So if I have 5 or a larger number, I have to round up. So my answer will be 5.383. Okay, let's do the last one. So there are no decimal places, right? But let's see what we get here. So if you do this calculation, you are going to get 7,000. Okay, now, how many significant figures do we have in 2,984? Well, we have actually 4 significant figures. How many do we have in 4,016? Again, 4 significant figures. How many do I have in 7,000 if it's written like this? Only 1, because the zeros are non-significant at the end of the number if there is no decimal point. So actually, I'm missing out on my accuracy. In order to show that actually I need to have 7,000 and all my 3 zeros are accurate, I need to add a decimal point at the end. And actually, it's better if I use scientific notation and I simply rewrite this as 7.000 times 10 to the. Let's figure out by how many places did we move our decimal point. 1, 2, 3. So 10 to the third. I hope this makes sense. I hope this is going to be helpful, and see you in the next video.